Hi guys, today we will discuss about how you can use the first and second derivative to help you find the point of inflection and stationary points. Okay, so let's have a look at this exam question. You got f of x is equal to x over 1 plus x cubed. So let's start from here. So this question asks you to work out the first derivative, which you can do on CAS because this one is exam 2. And it asks you to work out any point, any stationary point as well. So just sketch the graph and you can see that there's only one stationary point here, and it is a local maximum. The question didn't ask you to prove anything, so this one is sufficient. And the next part asks us to work out any point of inflection. Not like the stationary point of inflection could be quite hard to tell from the graph. So we need to have some good strategy. So firstly, you let the second derivative to be equal to 0. It tells us that you got two x value, 0 and 1.26. So once you got these two values, go back to the graph and you can try to trace. If you try to trace for point of inflection when x is 0, the case will say no inflection failed. Okay? And you can check the second x value here. In this case, the second x value will give you the point of inflection. And yes, you can just try to get this point here. Again, this part didn't ask you to prove anything, but let's say it does ask you to prove, yeah? So this is what you do. So you got your 2x value, and then you want to check left and right to see if you got the change in concavity, which is the second derivative. And make sure that when you choose value, you don't go past any asymptote or point of discontinuity. So in this case, when x is 0, so you can choose a value less than that, let's say negative 0.5. Because of vertical asymptote is x equal to negative 1, we don't want to go past that. So the second derivative turned out to be negative. And then you choose another value greater than 0. Again, you don't want to go past the second x value. So when x is equal to 1, so the second derivative is also negative. You can see there's no change in concavity. So that's the reason why when x is 0, you don't have a point of inflection. You can use the same method for the second x value 1.26. So you test left and right, and to the left, f double prime is negative. To the right, is it positive? So you do have a change in concavity in this case. So that's why this point is the point of inflection. So in HT, this one is, I say, a very tricky question. So let's take a bit of time to read. So f depends on x and also a parameter k as well. So we want to work out k so that we have no stationary points. So the first step, you want to find your first derivative. So for you to have stationary point, the first derivative needs to be equal to 0. So you make that equal to 0 and then solve for x. So you can see x depends on k, okay? If you don't want to have stationary point, that means these x values do not exist. And because we have the square root here, that means the term inside the square root got to be less than 0. So you can solve that on CAS for k. And then you got a range of k values. This is a tricky bit. So most people would have stopped here. The problem is we have not checked the denominator yet. So usually when you solve for something, it's a good idea to check the endpoints actually. So let's check the case where k is equal to negative 2. When k is negative 2, you substitute into here. So x turned out to be 1. And check another value when k is equal to 0 here. So x turned out to be negative 1. So the problem is You see how you got x squared minus 1 in the denominator. So x cannot be plus or minus 1. So that's why in your answer you need to include k equal -2 and k equal to 0 as well. Because when k are these two values, this one is not defined. So you cannot have stationary point when something is not defined. Okay, the last part. So this time again, we asked to work a case so that we have a point of inflection located on the y-axis. So you need to read and try to understand the question and see what equation you need to set up. So firstly, because of the point of inflection, we want to find the second derivative. And then we want to make that equal to 0. So you solve for h equal to 0, and then you got your x values here. Because it said located on the y-axis, that means x must be equal to 0. So the second solve, you want to let x equal to 0, and then you solve for k. So k turned out to be -1. And because there's only one k value here, you don't need to check for the change in concavity.